guys are doing good. This video is to review our essential skill polynomials/rational functions. So pause the video and copy down number 1 and see how far you can get, and then unpause the video and I will walk you through it step by step, but always good to see how far you can get on your own. Okay, so for polynomials, when we're given the equation, to find the degree, we add up all the exponents on every term that has an x in it. So 2 plus 2 plus 3 looks like 7. You might want to make a note for yourself. The leading coefficient is -3, so this is an odd negative graph. You probably have a chart that tells you about odd and even and positive and negative. Odd is like a line. Negative lines start up here and end down here. So this is up, down. Zeros, I go through every x and I do zero product property. So x equals 0, that one has a multiplicity of 2. X equals 4, that has multiplicity of 2. Multiplicity just comes from the exponent. Zero product property gives me -3 with a multiplicity of 3. Y-intercept, we got lucky. This one's going to cross through 0, 0, and the domain is always all real numbers. So let's sketch this. Pause it and try sketching it on your own if you'd like before I sketch it. So to sketch, we plot our zeros. So there's 1 at 0, 1 at 4, and 1 at -3. Then my arrows are supposed to be going starting from the top left and ending in the bottom right. Okay, then remember as you go through this, they're not necessarily in the same order they're written on your paper. So this first 0 from the left is at -3. That's this one. It has a multiplicity of 3, so I need to make it look like a cubic. As best you can. Cubics are hard to draw. Turn it around somewhere. We don't know how low it goes. Then my next 0 that I'm going to cross through is 0. 0 has a multiplicity of 2. So make it the vertex of a parabola. Turn it around somewhere. My next intercept is at 4. 4 is a multiplicity of 2 also. That is also the vertex or a bounce. And I landed on my arrow, so I probably did it right. Okay, on to the next type of question. Write a polynomial function in expanded form of least degree with integral coefficients. There's a lot of things in here you guys aren't remembering to do on test day. So I guess we can talk about them now. I'm also going to talk about it later. Function means f of x notation. Expanded form means you need to multiply it out. Least degree means don't add any extra roots that we don't tell you anything about. And then integral coefficient means whole numbers. So let's do this the easy way. If I'm given x equals -2/3, a lot of you don't write this down. A lot of you like to do this, x plus 2/3. Well, that is not an integral in an integer. It's not going to give you integral coefficients. So instead, check me if you don't believe me, 3x plus 2, that gives me the same 0 of -2/3, right? You minus the 2, you divide by 3. Start with whole numbers and you will end with whole numbers. Imaginary, complex, x minus 2 minus I. Notice I only gave you one. You have to remember they come in complex conjugates. So x minus 2 plus I is my other one. You cannot stop here because that would not be an expanded form. And you also can't add any extras because that would not be least degree. Start by making an area diagram and multiplying your two conjugates together. Nice things happen when we multiply conjugates together. Pause it and check it with mine. Okay, my work is on the side. I don't even fill in the 2 boxes that are going to cross out. I guess there's 4 boxes, 2 pairs of boxes that are going to cross out. -I squared is +1 plus the 4 gives me +5. Now you need to take those and multiply these together. We need the entire function in expanded form. Go ahead and pause the video, multiply those together, and see if you get what I got. Okay, check your answer with mine. Unless I made a small mistake, which happens, the answer should be f of x because that's the function part, equals 3x cubed minus 10x squared plus 7x plus 10. It's expanded form. I didn't add any extra stuff, and they're all integers. See if you can set up number 2. Pause the video and set up number 2. Okay, so a couple things. Root 3, x minus root 3, those also come in conjugates. That's a weird comma. X equals negative root 3 is one that you have to remember also. So that means x plus root 3 is a root. Then 1/2, hopefully you made that integral coefficients, 2x minus 1. Multiplicity of 2 means there's 2 of them. You could have just put a squared there, but I'm going to multiply them out anyways, so I thought I would write them twice. Here's what I want you to do. Multiply your conjugates, because nice things are going to happen. And then also multiply these together. And then unpause the video and check and see. That'll just be the first step. Check and see if you get what I got. Okay. X squared minus 3 for our conjugates, and then 4x squared minus 4x plus 1. Then, final step, multiply those together and see if you get what I got. Pause the video and write your final answer. Okay, unless I made a tiny mistake, which happens, I got f of x. Did you remember your f of x? Are you writing it as a function? Equals 4x to the 4th minus 4x cubed minus 11x squared plus 12x minus 3. Integral coefficients, expanded form, function, and its least degree because I didn't add in any extra roots. Okay, given f of x, find all the zeros. So this is p over q. Come up with a bunch of possibilities and do synthetic division till you find the one that works. I mentioned this in class briefly. It's not usually the way I do it, but you could also plug numbers in. So for example, if you plug in a and you plug it into your problem and you simplify it down, obviously this is just an a, so it's not going to simplify. But if you get an answer of 0, then x equals a is a root. I don't do it that way because, so it's a root. Now I have to do synthetic division with it anyways, so I might as well have just done it from the beginning. But I see that there might be some reason to do it that way. Whatever you'd like to do, see if you can find one of the numbers that goes in. Okay, so you might not find the same one that I find first, so I want you to just keep going. If you find one that works, just use it and keep going and see if you get the same answers at the very end, but realize the steps might not match mine at first. Pause your video. Okay, so remember, your steps might not match mine. You might have found a different one first, but I found that -1 goes into it. Now I got it down to a smaller polynomial. Now I'm going to do p over q with that one. So find a number that goes into that polynomial. If you really felt the need, this is 2x cubed plus x squared plus 18x plus 9. But I can't factor that by grouping or anything else, so I'm still left with p over q, so that's why I just make my synthetic division right underneath. See if you can find a number that goes into that one. Okay, so -1/2 goes into that one. So check out my synthetic division, see that it works. But notice now, when I go to write my equation, I'm going to divide it by 2. You have to remember that if you do synthetic division with a fraction, you need to divide by the same denominator. So this is really x squared plus 0x plus 9. And to finish this problem, I set it equal to 0 and do whatever necessary to solve that. Maybe it's factorable, maybe it's quadratic formula. This one, I just subtract the 9 to the other side and then square root both sides, plus or minus 3i. So my zeros are x equals -1, -1/2, plus or minus 3i. So remember, you use p over q until you get it down to a quadratic. Once you get it down to a quadratic, maybe it's factorable, maybe you use quadratic formula, maybe you just solve like I did in this example. Polynomial functions, K. Rational functions. Copy this problem down and work on factoring it. Pause the video and factor it. Okay, so I factored the top. I did grouping to factor the bottom, but I'm still not done because the bottom is still factorable. X squared minus 1 is x plus 1 times x minus 1, and then times x plus 3. So now it's in factored form. Make sure that's the one you're looking at right now. See if you can find any of these answers. Vertical asymptote, horizontal asymptote, slant, holes, zeros, pause it, and then we'll talk about it. Okay, I don't remember what colors I used in the notes, so these colors might not match. First thing I noticed is that there's a matching factor on top and bottom. That kind of erased it, but you get the idea. So that means there's going to be a hole. Zero product property, it's the factor x minus 1 that matches. Zero product property gives me positive 1. That's just the x value though. So when I cross those out, I'm left with x plus 2 over x plus 1, x plus 3. So now I know I need to find out what that equals when x equals 1. So plug 1 in. I get 4 over, this is 2 times 4, so 4 over 8, or 1/2. It's lucky that it worked out so nicely. Remember, there's always a possibility I made a tiny mistake along the way, just like anybody, so double check my work. Okay, so that gives me the whole. The ones that are left in the denominator give me vertical asymptotes. Vertical asymptotes, x equals -1, x equals -3. Make sure you write them as x equals. Checking the exponent's bigger on the bottom, so horizontal asymptote, y equals 0. I have a horizontal, so I cannot have a slant. Zeros come from anything that's left on top, so positive 2 is going to give me a 0 at x equals -2, and y-intercept, plug in 0. So I'm running out of space. I want to have space to draw this, but plug in 0. So I'm just gonna, if all x's are zeros, then I just get 2 over 1 times 3, which is 2/3. 0, 2/3. Okay, set up some axes. Vertical asymptote, x equals -1, x equals -3, y equals 0. Okay, then I have a hole at 1,1/2. Exaggerate the hole. I have a 0 at -2. And then I have a y-intercept at 0, 2/3. 0, 2/3. So we know this one's definitely up here. We don't know much else, so you're going to need to make a table and plug in some values. Okay, if you plugged in some values, this should be the general look of the sketch that you get. Honestly, I didn't want to make this one that hard. We're hopefully not going to make you sketch anything that hard on test day, so I'll make the one on the next page a little easier. Okay, copy down this one and work on factoring it. Pause the video and then unpause the video and see if you get the same factors as me. Okay, check your factors with mine. Then first thing you want to do is whole. See if you can find the whole. Pause it and see if you can do all the work to find the entire whole. X plus 2s are the factors that match, which means x equals -2 is the x value of the whole. Plug in -2 and you get 2 times -4, which is -8, but divided by -1, so 8. Now with your new equation, which is up here, see if you can find any and all other asymptotes. Pause the video and then check with me. Actually, see if you can find everything except for the sketch. See if you can do everything except for the sketch. Okay, so denominator, x equals -1, vertical asymptote. The degrees match, so leading coefficient 2 over 1, y equals 2, horizontal asymptote. Since there's a horizontal, there is no slant. Y-intercept, plug in 0 carefully, -4, and zeros, anything that makes the top of the function equal 0, so x equals 2. Draw some axes and plot what you already know. Okay, asymptotes are drawn. I plotted my whole. I exaggerated how big and open it is. Plotted my y-intercept, except I did not plot my y-intercept. For some reason I only went down to -4 here. And then I plotted my 0 at x equals 2. All of this tells me it's up here, touching the hole and hugging the asymptote, and down here going through both of those points that I know. Okay, hopefully this is some good practice for our polynomial rational expression function essential skill. I hope you guys are doing good.